Hello students, welcome to PRP lecture videos. In this video, we are going to see the topic covariance and correlation. Both are similar topic only. It will be very useful for statistics as well as communications engineering also. In communication engineering, especially signals, analyzing about the two types of signals. Okay, wow? Now in this video, let us see the definition of covariance and correlation, applications and examples. See one by one. Covariance definition is covariance is a measure of how two random variables vary together. If the variables tend to increase together, covariance is positive. If one tends to increase while other decreases, covariance is a negative. Okay. If both are not related, covariance is zero. So from this case, if we are taking two random variables only now, suppose here x and y, or x signal and y signal. If both signals length and strength is strong, covariance is positive. One increase, another decrease. One decrease, another one increase means covariance is negative. If both are not related, it is unrelated means covariance is zero. So from this zero itself, you can understand x and y are independent. Okay, right. Mathematical definition. Covariance of x comma y equal to expectation of x minus mean of x and into y minus e of y. While we multiply these two, we can get the simplified form covariance of x comma y equal to expectation of xy minus expectation of x into expectation of y. Okay. Suppose the sample data is given. Already we have seen, xi minus x bar into yi minus y bar, its summation divided by degrees of freedom n minus 1. Okay, that is by Bessel's correction. Okay, now n is the number of observation, x bar and y bar are the sample means. X bar is the sample mean of x and y bar be the sample mean of y. Okay, now see the examples. When we take two companies in stock prices, daily returns of company A and company B, okay, analyzing these two companies A and B by introducing the variable x and y. If when companies A stock goes up, B stocks also tends to go up. So both are having the positive covariance. Okay, both are in the same industry. For example, Tata Motors and Tata Powers or Tata Steel, like this. Negative covariance. Negative covariance when company A stocks rises, company B stocks falls. For example, competitors. For example, Airtel and Jio. Airtel and Jio. Okay, so both are not dependent, both are independent. Okay, right. Correlation. While we purchase the two stocks in a share market, we are using this concept whether we are keeping the 2A as it is or either choices to sell or not. So when we have to buy, when we have to sell. Already I have explained in normal distribution for the individual stock. Okay, now comparing the two variables simultaneously using the covariance concept. If it is positive covariance, let us keep this stock as it is. If it is negative covariance, better we have to think to sell. Okay, when we think that correlation is zero, both stocks are not related, so no need to apply the covariance between the two stocks. Okay, now if it is covariance alone is enough to keep this stock as it is, no. One more data also is required to confirm. That is what correlation. So correlation between these two random variables x and y is what we have found the covariance of x and y and divided by individual standard deviation. So ratio between covariance of x and y with and product of its standard deviations of x and y. So Rxy equal to covariance of x comma y divided by sigma x into sigma y. So the correlation coefficient gives the result. This is what covariance and standard deviation of y. Okay, what is the data? If R, we are finding this ratio between these two only now. If the answer comes minus 1 less than or equal to or less than or equal to 1. Okay, so minus 1, lowest range minus 1, top range 1. Okay, in between we can take the values. If R greater than 0, positive relationship. If R less than 0, negative relationship. If r equal to 0, no linear relationship. Okay, so already we have found the covariance between x and y, positive and negative are 0. And for one more confirmation, we find the correlation coefficient positive, negative and 0. Okay, so if when we take these two data simultaneously to check with two stocks or two variables x and y, it may be clear. Okay, see, let us see the types of correlation: positive correlation, negative correlation and zero correlation. Already I told you know, one variable increase, other variable increase. Example, height and weight. Okay, negative correlation. If one variable increase, other variable decrease, or here decrease, here increase, that is what negative correlation. Zero correlation, there is no relation. For example, shoe size and exam marks. Okay, once we ask the our kids why you are not doing the example, they simply tell, I used simply before I go to the exam hall, I think about that why I used shoe size. Okay, that's why I got low marks. So these are all not related socials and the exam marks. Okay, so we know that zero correlation. Okay, see the examples, variables and types of correlation and reason. Mostly, if the person having height, almost he is having weight. Okay, so this is x and y. So when the taller people generally weigh more, so positive correlation. When the currency value falls, immediately price of gold will be increased. That is what negative correlation. So people will think that if we increase number of hours for study, we can get exam marks also good. So student, if you extend your study hours, you may get a good exam marks. That is positive correlation. Okay, this is a well-known example. When we increase the temperature, electricity bill also increase. That is positive correlation. Now, black shirt and the exam marks. So there is no relation. Wearing black shirt and writing exam to get low marks and high marks. So zero correlation. Okay, so no relationship between them. Okay, for better understanding, I am taking two Tata Motors and Tata Power from the same industry. Let us keep X is the random variable. Random variable is daily returns of Tata Motors in percentage. Y is the random variable. Daily return of Tata Power in percentage. Okay, see, first day, second day, third day, 4, 5. X daily return 1.2 percentage minus 0.5 percentage, 0.8, 2.0 minus 1.0. And this is what Tata Motor. This is what Tata Power. See, from this itself, we can easily understand X also increase, Y also increase. X also decrease, Y also decrease. X and Y both increase, X and Y both increase, both decrease. So from the data itself, we can understand both are very together. Both are very together. But let us check with the data. Okay, find the mean values. I am finding the mean value of X. So what is the total value of here? 0.50. Total value of Y equal to, total value not 0.550. Sum of the values divided by 5 equal to 0.50. Sum of the values of Y equal to divided by 5 equal to 0.42. Okay, right. After finding the separate mean values, we are not simply sitting and watching the two stocks X and Y. Simply we are checking what is the cross multiplication. What is the cross relation between these two? That is compute X and Y. See, I am computing this product of X and Y. This is the data. Then after finding this multiplication, I found all are positive. So that is a good signal. That is a good signal. So what is expectation of xy? Sum of xy values divided by number of values 5. So what is the answer? 1.036. 1.036. Now we can easily find out covariance of x comma y. The formula is expectation of xy minus e of x into e of y. Okay, so 1.03x minus 0.50 into 0.42. What is the answer? 0.826. That is a positive covariance. So both x and y having a positive relationship from the concept covariance. So this is not only alone. to decide to keep Tata Motors and Tata Powers in our portfolio. Let us check with the correlation coefficient also, so that I need the further data. This is done by x minus x bar and x minus x bar whole square and y minus y bar whole square. We may get the sample standard deviation. Okay. Now we may use this data, or better we go along with the formula. What is the formula? Sigma x equal to expectation of x square minus e of x whole square. Sigma y equal to expectation of y square into minus e of y whole square. Now x square, x data square, y data square. Okay. Sum of all the value e of x square equal divided by 5 equal to 1.466. Okay. And sum of y square value divided by 5 equal to 0.742. Now already we have found e of x and e of y. Now we are going to find the standard deviation sigma x equal to substitute e of y square, e of x square minus e of x whole square. What is the answer? 1.103. And the standard deviation of y. Substitute the e of y square and e of y whole square value. We are getting 0.752. That is approximate value only. Now we found all the data, covariance and corresponding standard deviation. Now the correlation coefficient is covariance of x comma y divided by sigma x into sigma y. Substitute the value, we are getting the strong correlation 0.996. Okay, because r should be minus 1 less than or equal to r less than or equal to 1. If r value equal to 1, strong correlation, positive correlation. If r equal to minus 1, strong negative correlation. Okay, this is also almost 1 only now. So strong correlation. So now we have decided we can keep Tata Motors, Tata Powers in our portfolio. No need to sell. Okay. See this conclusion. E of x, E of xy, covariance of x comma y, individual standard deviation and correlation coefficient. Okay. From the given statistic, the correlation is strong so that Tata Motors and Tata Powers moves almost same level. Very strong positive correlation. Then see the both standard deviation also very low. Okay. Sigma x equal to 1.103, sigma y equal to 0.752. So what it shows that moderate volatility. Okay, so volatility is very, very low. So there is no problem to keep Tata Motors and Tata Powers. Okay. Also, we are checking with the covariance. That is also positive relationship. Okay. Now let us see the example for exam point of view. Calculate the correlation coefficient for the height in inches of father and son. So x, height of the father in inches. Y, height of the son in inches. Okay. So what is given? Heights of the father x in inches and height of the son in inches up to 67 to 71. Okay. Now number of observation 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8. Okay. Now let us going to find the correlation coefficient between x and y. See the table. Before we start the table, check the data. 65, 66, 67, 67, 68, 69, 70, 72, almost above 60 only. Okay. So when we find the covariance and standard deviation, we need x into y, x square, y square, and etc. So if you are keeping the same value, doing calculation is very difficult. Okay. So if you want to do manually, let us choose the new random variable x and b, x minus a and y equal to y minus b. So what about a and b? A and b, often we have choose the assumed means. When you first cite itself x and y, we may think that this may be the assumed mean. Let us choose the, you no need to take the perfect mean. Assumed mean is enough. Okay, well, then subtracting with the x, it comes the single digit. Okay, better to keep u and b as a single digit. That may be better. Now, when we do like this, the large numbers to smaller deviation. So making manual computation is good. Okay. And the correlation coefficient. Okay, after replacing x and y by u and v, is there any changes in correlation coefficient? No. Correlation coefficient is independent of the change of origin. That means subtracting constant, addition of constant, there is no change. Scale, multiplying by constant also, there is no change. Okay, va? So we don't need to worry about that, to keep u and v instead of x and y. Okay, now the correlation coefficient rxy. Okay, now introduce a new random variable u and v. See, r correlation coefficient of x and y is nothing but correlation coefficient of u and v. So what is the formula? Covariance of u comma v and divided by sigma u into sigma v. So find one by one. What is covariance of u comma v? Expectation of uv minus expectation of u into expectation of v. Okay, so let us find expectation of uv by summation of uv divided by n. U bar is nothing but mean of u, summation of u divided by n. V bar is nothing but mean of v, summation v divided by n. Okay, now the standard deviation, variance sigma u square equal to summation u square divided by n minus u bar square. Variance of v equal to summation v square divided by n minus v bar square. Okay, now you'll form the table by taking a equal to 67, b equal to 68. So see, x and y are given. U equal to x minus 67, v equal to y minus 68, and see, all the x and y 2-digit goes to single digit. Okay, find u square, v square. So for example, 65 minus 67 minus 2, 67 minus 67, answer 0, like this. 72 minus 67, 5. So see the square, 4 1 0 0 1 4 3 square value 9, 5 square value 25. Like that for v square, and u into v, minus 2 into minus 1 2, minus 1 into 0 0, 0 into minus 3 0, 0 into 0 0, like this uv. So sum of all the u, answer is 8. Sum of all the v column, 8. Sum of u square value equal to 44. Sum of v square equal to 52. Sum of u equal to 32. Okay, see the table. Sum of u, sum of v, sum of u square, sum of v square, sum of uv for our convenient. So sum of expectation of u equal to summation of uv divided by n. So what is the answer? 32 divided by number of observation 8. So 32 by 8 equal to 4. Next, e of u equal to summation of u divided by 8. So 8 by 8 equal to 1. Same way, summation of v, e of v equal to summation of v divided by 8, that is equal to 1. Okay, so this is record data for covariance. So covariance of u comma v equal to 4 minus 1 into 1 equal to 3. Now we are going to find the standard deviation. So that first, e of u square value, sum of the u square 44 divided by 8 minus e of u, already we know 1 square upper 1. So 44 divided by 8, 5.5 minus 1 equal to 4.5. That is the variance. Now what is standard deviation? Sigma u root of 4.5. Okay, then variance of v, e of v square minus e of v whole square. Okay, so substitute e of v square value, summation of v square equal to 52 and divided by number of observation 8 minus e of v, already we know 1. So 52 divided by 8, 6.5 minus 1 equal to 5.5. So what is the standard deviation? Root of 5.5. Now we are having the required data to find the correlation coefficient. So covariance of u comma v 3 divided by sigma u root of 4.5, sigma v root of 5.5. So what is the answer? 3 divided by 4.7949, almost equal to 0.603. So this is not a strong correlation, positive correlation. Okay. Thank you.